Q4. We have a straight wire carrying a wire passes between two bar magnets. What's the direction of the magnetic force? I can see that the current is up. The magnetic field كيف? From left to right. Okay. I put my thumb up, my fingers to the right. How is it? Alright, so F is cross ولا dot? Into. So it is into. Two parallel wires Y, X and Y carry equal currents as shown below. Which arrow correctly shows the direction of the resultant field? So it is outward, it's curling. How is the magnetic field? Clockwise or counterclockwise? So outward, counterclockwise. When it comes here, it is almost like this. Okay? So it's like so. The second one also, how is it? Counterclockwise. When it is curling, how is it? Sorry. Okay, so it is also like this, right? So the resultant is C. That's what we agreed on, right? When charged particle of mass m and a charge q move in a uniform magnetic field, then a magnetic force F acts on it. What is the magnetic force on the particle? Is that the mass is 2m and the charge is 0.5. So we have a charged particle moving. Yani the force is Q, V, B, sine theta. The only thing that I change is 0.5. Where do I put this change? Doesn't have any significance. So it is going to be 0.5 F. A straight wire carries a current of 5 amps I. At what distance from the wire the magnetic field strength due to the current in the wire is 0.1 millitesla. So how do I do it? B equals to mu 0 I over 2 pi r.
Can you scroll down?
Sure. So 1 times 10 to the power of negative 3 equals to 4 pi 10 to the power of negative 7. I is 5. And 2 pi r, I don't know. Okay, so basically it will be 1 centimeter. So R equals to 1. Yeah, 0.01 meters, which is 1 centimeter. So yes, 3 equidistant and parallel. 3 equidistant and parallel wires X, Y, and Z carry equal currents I in the same direction. Indicate the direction in which wire Y moves. اتفقنا to discuss each two على slope, right? So X, Y, what do? They attract, right? So this means that Y will be attracted to the left. This is Fx. And Y with Z also, what do? Also they attract. So F of Z is like so. So شو بتعمل الwire? Doesn't stays in place. A straight horizontal wire carries a current of 3 amps. A length of 4 centimeters of the wire is subject to a horizontal magnetic field between the poles of a magnet, a magnetic force of 14 millinewton. So honey, the only difference is that I have to multiply by 10 to the power of negative 3 acts on the wire. Determine the magnetic field strength. B equals to how is it? B equals ولا F equals? F equals to I B L sine of theta. It is 14, 10 to the power of negative 3. I is 3.5. B, I don't know. L is 4 centimeters perpendicular, يعني sine of 90. أهم شيء, what's the unit of the magnetic field? 0.1 Tesla. State the direction of the magnetic force. So I will point my finger in my thumb is in. My magnetic field is, how is it? From out of the north into the south. Okay, بتطلع تحت مظبوط. So it will be down. You have a straight wire of length 2 meters, carries a current of 24. It is placed on a horizontal tabletop in a uniform horizontal magnetic field. The wire makes an angle of 30 with the magnetic field lines if the magnitude of the force is 0.5 Newton. What is the magnitude of the magnetic field? So again with the same equation, I B L sine of here 30, replacing everything by its value. B, the length is 2, sine of 30. B is 0.02 Tesla. Finally, in a laboratory, electromagnet produces a magnetic field of magnitude 1.5 Tesla. Okay, so we removed this one. We said it's an electron, it's an electron, it's an electron, because we have the mass and the charge of an electron. Moves through this field with a speed of 6, 10 to the power of 6. Find the magnitude of the maximum magnetic force على moving charge. F equals QVB sine of theta. So basically it is perpendicularly, it is moving normally, So the force is Q. I take it in absolute value, girls, again and again. Velocity 6 10 to the power of 6. B is 1.5 sine of 90. So the force in Newton is, I believe, 1.44 10 to the power of negative 12 Newton. Now that I have the force, how can I find the acceleration? What's the equation that links force and acceleration? F equals to ma. Amazing. I have the mass up. So 1.44 10 to the power of negative 12. 12, huh? Not 19. Okay. Equals to the mass 9.11 10 to the power negative 31 multiplied by A. A should be in meters per second squared. It is 1.58 10 to the power of 18 meters per second squared. Thank you.